Section 3.6. What's a reasonable task for a function? There's no clear rule for what makes a good function, but there are some intuitions and recommendations we can share. Make no mistake, though. Identifying good functions is a skill that takes time and practice. To help you with this, we gave you some examples of good functions in Section 3.3. In this section, we'll outline our recommendations and provide you with some additional good and bad examples to help build that intuition. Section 3.6.1. Attributes of good functions. Here are some guidelines that we believe will help you see what makes a good function. One clear task to perform. A leaf function might be something like compute the volume of a sphere, find the largest number in a list, or check to see if a list contains a specific value. Non-leaf functions can achieve broader goals, like update the game graphics, or collect and sanitize input from the user. Non-leaf functions should still have a particular goal in mind, but they are designed knowing that they will likely call other functions to achieve their goal. Clearly defined behavior. The task find the largest number in a list is clearly defined. If I gave you a list of numbers and asked you for the largest number, you know what you should do. In contrast, the task find the best word in the list is poorly defined as stated. You need more information. What is the best word? Is it the longest, the one that uses the fewest vowels, or the one that doesn't share any of the same letters as Leo or Dan? You get the point. Subjective tasks aren't great for computers. Instead, we could write the function, find the word in the list that has the most characters, because what is expected is well defined. Often, programmers can't put all the particulars of a function just in the name, so they fill in the details in the docstring to clarify its use. If you find yourself having to write more than a few sentences to describe the function's behavior, the task is probably too much for a single function. Short in number of lines of code. We've heard different rules over the years for the length of functions, informed by different company-style guidelines. The lengths we've heard vary from 12 to 20 lines of Python code as the maximum number of lines. In these rules, the number of lines is being used as a proxy for code complexity, and it's not a bad rule of thumb. As programmers ourselves, we both apply similar rules to our code to ensure the complexity doesn't get out of hand. With Copilot, we can use this as a guide as well. If you ask Copilot for a function and it gives you back 50 lines of code, this probably isn't a good function name or task. As we discussed earlier, that many lines of code are likely to have errors anyway. General value over specific use. A function that returns the number of values in a list that are greater than 1 might be a specific need for a part of your program, but there's a way to make this better. The function should be rewritten to return the number of values in the list that are greater than another parameter. The new function would work for your use case. Give the function 1 for the second parameter, and for any value other than 1. We strive to have functions be as simple but as powerful as possible. This is why we wrote our function in Section 3.3.1 to work for any stock, not just Apple. Clear input and output. You generally don't want a lot of parameters. That doesn't mean you can't have a lot of input, though. A single parameter could be a list of items, as in our best_word function in Section 3.3.5. It does mean that you want to find ways to keep the number of inputs to a minimum. You can only return one thing, but again, you can return a list so you aren't as limited as it may appear. But if you find yourself writing a function that sometimes returns a list, sometimes returns a single value, and sometimes returns nothing, that's probably not a good function. Section 3.6.2. Examples of good and bad leaf functions. Here are examples of good leaf functions. The function is on the left in italics, and the goal of that function is described on the right. Compute the volume of a sphere. Given the sphere's radius, return its volume. Find the largest number in a list. Given a list, return the largest value. Check whether a list contains a specific value. Given a list and a value, return true if the list contains the value, and false if it does not. Print the state of the checkers game. Given a 2D list representing the game board, output the game board to the screen in text. Insert a value in a list. Given a list, a new value, and a location in the list, return a new list that is the old list with the new value inserted at the desired location. Here are examples of bad leaf functions and our reasons for why they are bad. Request a user's tax information and return the amount they owe this year. Perhaps in some countries this wouldn't be too bad, but we can't imagine this as a single function in either the United States or Canada given the complexity of the tax rules. Identify the largest value in the list and remove that value from the list. This might not seem so bad, but it's really doing two things. The first is to find the largest value in the list. The second is to remove a value from the list. We'd recommend two leaf functions, one that finds the largest and one that removes the value from the list. However, this might make a good non-leaf function if your program needs to perform this task frequently. Thinking of our dataset from Chapter 2. Return the names of the quarterbacks with more than 4,000 yards of passing in the dataset. This has too much specificity. Without a doubt, the number 4,000 should be a parameter. But it's likely better to make a function that takes as input the position, quarterback, running back, the statistic, passing yards, games played, and the cutoff that we care about, 4,000, 8,000, as parameters. This new function provides far more capability than the original, allowing a user to call the function to determine not only the names of particular quarterbacks who threw for more than 4,000 yards, but also, for example, running backs who had more than 12 rushing touchdowns. Determine the best movie of all time. This function is too vague. Best movie by what definition? What movies should be considered? A better version of this might be a function that determines the highest rated movie by users given at least a minimum number of ratings. This function would likely be part of a larger program where the function would have data from a movie database, say IMDb, and minimum number of user ratings as inputs. The output of the function would be the highest rated movie that has at least as many ratings as specified. Play Call of Duty. This might be the main function in the large code base for the Call of Duty game, but it's definitely not a leaf function. Overall, in this chapter, you've learned about functions in Python and how you can use Copilot to help write them. You've also learned about the characteristics of good functions and how important it is to make sure your functions are solving tasks that can be managed well by Copilot. Our next steps in this book all revolve around understanding whether the code produced by Copilot is correct and how to fix it when it isn't. In the next chapter, we'll start by explaining the basics of being able to read the code produced by Copilot, because this gives us the first sanity check for whether Copilot is doing what we think it should be. Then, in later chapters, we'll dig deeper into how to carefully test the code and what to do when it's wrong.